Okay, well, it's 1:15, so I'll get started. Thanks for joining me here today. I'm Matthew Revell. I'm from a company called Couchbase. We make an open source distributed database system called Couchbase Server. And we also make Couchbase Mobile, which is an embedded document database for iOS, Android, and Xamarin. All open source. You can find it all on GitHub. And I'll leave that bit there. So, yeah, I want to talk a little bit about SQL and querying databases and what we've been doing for NoSQL databases. So, you know, the title of my talk is SQL's back, but in a lot of cases, really, you're probably thinking, well, SQL didn't really go anywhere. Because for the vast majority of queries that we do in the vast majority of use cases, relational databases using SQL are still what's going on, and non-relational databases are very much a niche still, albeit a growing and an important niche. So, yeah, it's true that relational databases, SQL didn't go anywhere, but in terms of NoSQL databases, they have defined themselves by the very fact that they don't have SQL. And so if you want to look back maybe 10 years to when the current crop of open source non-relational databases really made their first trip out into the world with CouchDB, then they were looking to solve different problems to that of query. So CouchDB was about scale, about flexibility in terms of schema. Then others came along, and again, they were looking to solve problems of uptime, availability, fault tolerance, and scalability. Querying always came second. And despite the various different types of non-relational models, you know, key value is still about primary key lookups. Columnar databases like Cassandra, to start with, okay, they have SQL now, but to start with, it was really about primary key lookups with some caveats around key spaces and columns and things like that. And then document databases were perhaps the ones that had some more nuanced querying than just pure key value lookups. But with CouchDB, it was about writing MapReduce queries. With Mongo, it's been about using their own querying system. So SQL didn't get a look in anywhere. And that seems a shame, really, because SQL is, you know, something that we're all familiar with. A lot of our tooling works with SQL, so, you know, why ditch it? Why set up an entire load of databases in opposition to SQL? Well, it was never really about being in opposition to SQL. It was just non-relational. But all of these databases had in common that they were offloading more and more of the workload to the application layer that traditionally would have been done by the database or tooling around the database. And I don't know if you've seen this cartoon, but there's you know, like the idea that really these things weren't databases at all. They were just tools for storing data, and you did the whole rest of it yourself. You know, you got to feel the pain, and that was tough because you were looking for scale, for example, rather than queryability. But you know, things are maturing. It's not all just about MapReduce in Erlang anymore. So at Couchbase, we really wanted to make good on our promise that Couchbase is a document database rather than just a key value store. And there were various ways that we could have approached that. So we still have the MapReduce thing where you create secondary indexes by emitting certain keys from JSON documents by writing a little bit of JavaScript, in this case, not Erlang. But, you know, SQL's not going anywhere. It's one of the few languages that's still in use every day, despite being about 40 years old. Okay, it's had some tweaks along the way. And we see Nickel, as we call it, as a tweak. So Nickel looks a bit like this. You are basically pulling out key value pairs or entire JSON documents or JSON documents that have been nested within other JSON documents, and then emitting them just as you would emit rows with a SQL query. So here, you know, a bucket is a kind of a namespace in Couchbase, but so you're selecting from a bucket, so very much like selecting from a table. You're specifying your kind of query parameters as normal, and that's it really. It's very, very familiar. So why Nickel? It's non-first normal form query language. So one of the things about relational databases is, you can only have one piece of data in every single cell. You can't have nested data because that would break the first normal form. Whereas JSON is very much built around nested data, around having denormalized data. So we wanted to build a version of SQL that would work with nested JSON data. And it was very important for us that Nickel should basically be SQL. There shouldn't be too many surprises. So it conforms pretty much to the SQL++ ideas from the University of Berkeley, California. And Nickel is basically the closest to the SQL++ paper of the various different query languages around NoSQL databases. And there's also native Java SDK APIs, so you can chain methods instead of writing the actual Nickel queries. It's link compatible for the .NET programmers, and there's an ODM for Node.js as well. So if you're used to using something like Mongoose, then it shouldn't be too much of a surprise to move over to Ottoman, which is our ODM, Ottoman, Couch, so on. And probably the most interesting thing for most people is it does document joins. So you can now, using Nickel, you can join two documents together using their primary keys, and get a lot more queryability from a document database. You still get the scale, you still get the uptime and all of that. And in Couchbase's case, you still get the fast response time, so it's got built in Memcached, but you also get this queryability. So what are we giving you? I mean, it really is just SQL, really. There are a few changes, but here there's no surprises, really. You're doing all your usual things. You're selecting from a bucket or a key space, as we call it in Nickel. Like I say, you can join into other documents or cross key spaces. You can specify the parameters for when to return something. You can group things. You can order them. All the stuff you'd expect. Yeah, and you can also modify data using Nickel as well, just as you would expect with SQL. So you can update documents, you can insert keys and value pairs into documents and so on. So it gives you much more that level of queryability that you would expect from a database, rather than just something where you're a black hole where you're throwing data and then hoping it comes out again if you can remember the key name. So I'll quickly show you a demo of this in action. Okay, so here's Couchbase Server's web interface. And this is a travel sample. Travel sample. So we've got a bunch of data about airlines and airports and things like that. And this is what one of the documents looks like. So fairly simple stuff. It tells us about an airline called 40 Mile Air. We move on a little bit in the data set. And maybe we'll find an airport. Let's have a look. And here we have Biard Airport in Poitiers, France. So that's the sort of data we've got here. So we can open up a little command line query thing called CBQ, Couchbase query, and we can try and write a query select star from, sorry for sniffing, got hay fever, from travel query, travel sample, select star from travel sample where type equals airport. And this is not going to work. Got an error, no index. So there are two types of index you can build with Couchbase. The one that we're going to use today is our dedicated global secondary indexes, they're called. And what they require is that you first build an index of all the documents in the bucket. And when you do that, effectively every query that you can do from that point will then do the equivalent of a table scan across all the documents, which if you've got millions of documents is going to be, or even thousands of documents, is going to be horrifically inefficient, but let's try one. So let's create an index, create primary index on, what was it called, travel sample, using GSI. So that's the type of index we're going to use. The other type is the MapReduce type of index that you can create a view similar to CouchDB. This time we're going to use a GSI. So we've created the index now. So now we have an index of all the key names. Not terribly useful, but it's our first route in. Now we can do that. Select star from travel sample where type equals airport, and that gives us all the airports. So we've got 1,968. So that's okay. And we can have a quick look at what's actually going on there. By doing explain select star from travel sample where type equals airport. And here we'll see that it's used, it says operator primary scan index is the primary. So that's shown us that it's doing that full table scan. So to be a little bit more efficient, create an index called airports on travel sample where, travel sample type where type equals airport. And again, using GSI. So that's created our index now, and if we run that again, this time it'll say that we've used the index airport. There we go. So now we're being much more efficient about it. Now, in this case, because we've only got a small set of data and we're doing one query, it's not going to show much difference. But yeah, in actual production, it would do. And so we could do much more interesting things. So we've got restaurants in this data set as well. So we could do something like select star from, or select. Let's not select just that. Let's select name from travel sample where activity equals eat and city equals London. So let's find some restaurants to go to. And I made an error, I think. I know. Okay, sorry about that. Let me quickly remind myself of what I did earlier. Okay. All right, there we go. So now we've got 65 restaurants that we can find, and again, we can now make an index on those restaurants if we want to. We create a restaurants index, so now we've got a route into. We're basically creating an index based on data that isn't necessarily in the documents itself. You know, there's nothing that says that the restaurants, but we could create a restaurants index. And I've got about 2 minutes left, so if there's any questions. Yeah.
Which is the difference between result count and result size?
Result size, I think, is bytes, or, yeah.
Okay.
Yeah.
Can you show an example for nested documents?
Not with this data set, sorry, no, so it's not nested, but I can direct you to look at some of the things we've got online. So if you go to nickel.couchbase.com or to our documentation site at docs.couchbase.com or the blogs.couchbase.com, you'll find, blog.couchbase.com, you'll find a bunch of videos and examples there where they go into much more detail than I've probably got time for now of nesting and unnesting documents.
Is this released? Last time I saw you guys speak, it wasn't quite.
Yeah, so it's in beta now. You're probably looking around August sort of time, but we do actually have DirecTV in America. They're like the Sky TV equivalent. Have actually gone into production with the beta for their TV listings on their TV guide. So now they can do much more interesting ways of navigating their TV listing data based on the things that you put into the user interface. Yeah.
I was just about to ask, are there any sort of larger scale use cases?
Yeah, not yet. I mean, that's probably the big one, but because it's been in beta, we haven't. Yeah, we don't have any big name examples yet, other than that. But yeah.
Is that the only query language? Because presumably Nickel's new for you guys.
Nickel's new, yeah.
So before you had some kind of JavaScript style.
Yeah, so you would write.
still produce-
Yeah, so you can still do CouchDB style views, so that secondary index is created with the JavaScript MapReduce function, and yeah.
Is one perform better than the other, or do they reduce down to the same?
They're different. I mean, so the secondary indexes that Nickel uses are built using our new Forest DB key value store underneath. So and they're also built using indexing services across the whole cluster, and you can separate out and create dedicated indexing servers. Whereas the MapReduce stuff is kind of spread across to each index is generated where the data lives. So it has a different scaling profile, I guess. Basically, Nickel, once it's in production, is probably the preferred way to query and index stuff. The MapReduce stuff will stay there for things like, mostly for the reduce side, really, creating aggregates of, how many people clicked this or whatever, that sort of stuff. But I'm getting flashed out now. So we're at booth B3 upstairs if you want to come see us. There's a bunch of us there from Couchbase if you want to talk. So thank you very much. Cheers.